Hey guys, we're still looking at lesson 4.1, relations and functions, and we're going to go over a few examples here to get you guys started on your assignment. So first question, it says, determine whether each relation is a function. All right, so if we have to determine whether something is a function or not, you have to understand or know what a function is. So definition, a function is a relation in which every domain value corresponds to exactly one range value. That means every number in the domain is unique. And remember, your domain is your x values, okay? Your range is your y values. All right, so determine whether each relation is a function. So we want to determine if all of our x's are unique, or if there's exactly one x in this set of data. So if we look at number 7, 3, 1, 4, 6, that is yes. This one is a function. Okay? So you can either write yes or you can put function. Let's write function on here. All right, number 8, we've got -1, we've got -2, -3, and -2. Because -2 shows up twice, number 8 is not a function because the x's are not unique. Again, we don't even have to look at the y's in this case to determine whether it's a function or not. We're only looking at the domain, which is the x values. All right, so let's look at what it asks down here. For each function, find f of -1, f of 1, and f of 3. So what they want us to do is, remember this is function notation, f of x. So if this is f of x, they're wanting us to substitute these values in for x to find the y value. So for the first one here, if we have f of -1, they want us to plug -1 in for x. So we're going to have 3 times -1 minus 4. So f of -1, this is kind of like just the name of your function. This is our y value. That's what we're trying to find. So 3 times -1 is -3. -3 minus 4 is -7. So when x is -1, -7 is f of x. So we can say x, y, or we can say x and f of x, which is the same as x and y. For this case, our x was -1 and our y is -7. So that would be the ordered pair that comes from that expression here. Remember, this is just your function rule. This tells you what to do to x. We're going to multiply it by 3 and then subtract 4. All right, for number 10, f of x equals 4. Actually, let's not do this one. Let's go ahead and plug in f of 1 and f of 3 to this same function. So if we look for f of 1, we're going to do the same thing. We're going to substitute 1 in for 3 times 1 minus 4. So f of 1 is 3 minus 4. This time it's -1. So f of 1, so we're going to have 1, -1. So this is a point on this line or on this function, and this is also a point on this function. All right, so we're going to look at one more, f of 3, and we're going to do 3 times 3 because x is 3 in this case, and then minus 4. So we're going to have 9 minus 4. So f of 3 equals 9 minus 4 is 5. So 3, 5 is another point on that line here. Okay? All right. This example says the cost C in dollars of a large pizza with T toppings is modeled by the function C of T equals $10.95 plus T. And remember, T is toppings. All right, so it says, what do C of 0 and C of 2 represent? Well, C of 0 would represent no toppings. Since T represents toppings, if we substitute 0 in here, that means we're getting no toppings on this pizza. So you can see a large pizza is $10.95. Each topping is $1. All right, so C of 2 would represent 2 toppings on this pizza. Okay, so it says find C of 0 and find C of 2. So C of 0 equals $10.95 plus 0. So 0 toppings, your pizza costs $10.95. If we get 2 toppings on our pizza, C of 2, it's going to be $10.95 plus $2. So it's going to be $12.95. So 2 toppings cost $2 more than no toppings. All right, it says graph the function. We're going to look at graphs a little bit later, but it says graph the function with an appropriate domain for this real-world solution. Is the domain of a function all real numbers? So the main thing about the domain here is you can't have negative toppings. So you're going to have just points on the graph, and you're not going to have like a half a topping. You can have a pizza with half the pizza with a topping, but like each topping is going to be like $1 more. So that's what it means to explain in a real world situation. So you got to think about it as far as the pizza and the toppings go. So your domain would be your positive integers. All right, the next one says for each relation, create a mapping diagram and give the domain and range. Okay, so remember the domain and range. All right, your domain and your range. And your domain is going to be all your x's, remember. So we're going to put our x's in first. So 2, 5, 6, 7, 3. So this would be our domain. And our range would be 0, -2, -5, 3, and 1. So our range would come from the y values. And then if you wanted to create a mapping diagram, 2 goes to 0, 5 goes to -2, 6 goes to -5, 7 goes to 3, and 3 goes to 1. That one's pretty easy because each element in the domain goes to exactly one element in the range. All right, this one says use a vertical line test. So I've tried to create a vertical line here. All right, so if we go from left to right across through here, you can see it's just going to hit 1 point at a time. So using a vertical line test, we can determine very quickly that this represents a function. Again, remember, if it passes the vertical line test, then it is a function. So 16 is a function. All right, number 17. If we take, oops, I'm dragging the wrong thing here. All right, if I take my line here and I look, you can tell that it crosses in multiple places. So because the vertical line hits here more than once, number 17 is not a function. All right, so let's look. Oh, again, dragging the wrong thing here. All right, so you can look at this one. So this one passes 1 point at a time. That is a function. And this one, the circle, you can see that it passes more than 1 point at a time. So that one is not a function. So again, this one is function. Passes the vertical line test. This one is not a function. All right, this says use the graph of f to determine each indicated function value. All right, so this says f of -6. So remember, this is f of x. They're given an x value. So when x is -6, this is our x-axis here. Horizontal is always the x. We got 2, 4, 6. So negative 6, we go up to 5. Negative 6 goes with 5. Negative 4 is at 0. F of 0, we go down. 0 is at negative 4. And then f at 4, if I go 4, that's 4, 0. And then f at 6, 4, 6, 8. So this is 6 right here. I go up, and 6 is at 5. So all we're doing is finding the ordered pairs there. This is just function notation and asking us how to find those ordered pairs that fit on that curve. So you can see each of those points is on the graph. All right, these say use the table of values to determine if the relation is a function. Again, function is a big deal, so you got to know the definition. So we know that all x's are unique. It is a function. So all we're going to do is look at the table, negative 2, negative 1, 0, 1, 2, 3. This one is a function because all the x's are unique, okay? This one has 1, 2, 3, 1, 4, 5. Because it has 1 twice, then this one is not a function. Okay, that's all the examples for today. So good luck on your homework. If you have any questions, please let me know.